Welcome back to Incremental, the continuous improvement podcast. I'm Devin Bedoni.
And I'm Uriel Eisen.
Today, we are going to do a little more of a in-depth exploration, I guess might be the best word, of push, pull, and flow systems. And what does that actually mean? We've been getting some good feedback that maybe we need to go into the basics a little bit more.
Yeah.
I think we've been hesitant because we don't consider ourselves to be experts or really in a position to be teaching about lean/TPS, but clearly we need to fill out the vocabulary a little bit for everybody, for us all to kind of have this conversation together.
Yeah. And I guess we've been reading/talking about it for the past 2 years. So I feel like
there's some embedded info there.
Yeah, we forget about. A nice quote for this episode, flow where you can, pull where you must, from Rother and Shook. What does flow mean and what does pull mean?
So it seems like if I were just to, hazard a description here, pull indicates that there is inventory that you are pulling from. And flow would be that something flows continuously from raw material to finished goods to or all the way to customer without stopping, I think.
Yeah.
Yeah. But as discussed many times, both by us and others, actually doing that is incredibly challenging. So I think this quote kind of dives into the fact that some amount of inventory between processes is usually required, except in extremely
and not in all between all processes. So we've clearly identified in our shop where the breaks are in our flows.
Yeah.
So we have different cells that flow.
Sure.
But I guess just to sort of talk about it a little more, so kind of started off as a push production system, mass manufacturing years ago was sort of a push production system, which is essentially where a very fast process, whether that's a department or a factory or a machine, is essentially just produces a bunch of stuff because you have time scheduled there, right? So it was sort of in the automotive industry, those were often the presses. They're pressing out body panels, and it would take them 4 days to set up a new set of dies. And so now that we have them on that machine, let's just run it. And it has nothing to do with how much is needed, really.
Yeah, I think the dividing line, more globally, might be whether somebody has ordered it.
Kind of. I think, I think that's meant to be the line. I think even when you're doing a pull system, it's sort of just a much smaller batch size, but it still can exceed orders at any given time,
Mm-hmm.
right? Your inventories.
It's still anticipatory.
It is anticipatory, but it's very different to build a year of inventory or 6 months of inventory than it is to build much less, a week or an hour of inventory.
Yeah.
Also, the idea with a pull system is you often use Kanban to trigger that production, and the Kanban only triggers when orders have been have used up the stock that you are now replacing. And so even if it is ahead of demand slightly, it is responding to demand.
It's reflective of actual demand.
Yeah. And so I think, we were sort of talking about this briefly, but I think our background, not having seen mass manufacturing in its heyday,
mm-hmm.
right? With Ford or
anything.
Yeah, or just really large companies that have no essentially ways of suppressing production. And that's sort of the big thing across a lot of these different systems. The production line, we've talked about this before, but basically the production line that Ford pioneered for automotive stuff anyway, that suppressed overproduction by just spatial constraints. So on a production line, you don't have...
There's a car in front of the car. that you're working on.
Yeah, it's like,
Yeah.
well, yeah. And then with lean or TPS, I guess it was like the Kanban card. If you don't have a Kanban to produce for, you don't produce.
Yeah. I wonder also if there's, I'm not educated enough to know this for sure, but I wonder if part of it is a product of the times that they evolved in.
Mm-hmm.
And I guess we would have to look at actual sales, but I imagine that, um, at the time that Ford was developing their style of production, there was probably a fairly limitless demand
Yeah,
comparatively.
there basically was,
Yeah.
right?
And so I think at the time it was like, make as much as we can. I think there
Yeah.
were models that didn't sell as well, and I'm sure they responded to
Not
that.
not only, yeah, and then some very interesting things, which so I
So
was talking, yeah,
I was just to finish that, I guess a push system evolved in that time because the demand was there to absorb all of everything that was pushed.
right.
And now we're in a little bit of a different scenario, or I don't know, maybe not with like iPhones or something. Like they probably can make as many of those as they want and they will sell.
Yeah, and I think there's a couple things in there. One, just because they'll sell does not mean they were produced as efficiently as possible. So it does
Sure.
turn out that there's a lot of inherent waste in overproduction.
Yeah.
Um, and then the other piece is that there's a lot of other issues, hence the inefficiency, like damaged goods or defects you didn't catch but produced 6 months of inventory with a defect that now either needs to be reworked or it scraps the batch. Like
Yeah.
there's a lot of other elements that make it a bad idea to do a
Mm-hmm.
push system. um yeah.
I think it's worth like just all of us, when you think about it, also you can break this down into like the overall system can be push or pull. Within that, you can have aspects like station,
Totally.
between station, it could be push or pull
Right.
or flow. Within a station can be push or pull or flow.
Yeah, and one we're all probably guilty of is thinking about our ship station as a push, right? Production drops a whole bunch of stuff on shipping, and then the shipping department needs to get that all out to customers.
Mm-hmm.
Even though theoretically, if we were, maybe not even theoretically, maybe I can think about that in our shop. What is the ideal load on our shipping station, and how do we level production, and how do we only produce upstream at a pace where our shipping station can respond, and rather than building up larger areas for things to accumulate, it would be better to suppress production upstream, or more likely
Mm-hmm.
to increase capacity or decrease tack time or decrease the sort of peaks and valleys of the shipping station.
Yeah.
Um,
It seems like, maybe I'm wrong here, but it seems like shipping is a very easy thing to level because people expect some, variability in delivery date. And so like pushing some overwork into the following day to level that out seems like a really easy way to handle it.
True. Yeah. And I think for a lot of smaller shops, it is nowhere close to a bottleneck. So it's maybe,
Mm-hmm.
but just to your point, right? We're all pushing and pulling and flowing, just not really being super intentional about it. I was talking to my brother Elisha about, he's in the restaurant industry, and we've sort of been discussing how to make a kitchen lean, which is
Super lean.
which is challenging to think through. But
Yeah.
and this for some reason never sunk in for me. He texted me about basically doing prep of a large batch, which is very typical, right? You'll prep the stuff you need for the day.
Yeah.
There is inherent waste in, and they talk about this in Total Production System and every other book, but
Mm-hmm.
there's inherent waste in putting it away to get it back out to do more work on it.
Sure.
Right. So like you prep a whole bunch of whatever, I'm not in a kitchen, but let's say you chop up a bunch of cucumber and you dump it in a bin. And then
Cucumber, interesting choice.
what do you go with? What's your preferred veggie?
I guess I had onions in mind.
Interesting.
I chopped a lot of onions as
Let's
in
go
my
onions.
day.
So you take them off your cutting board and you put them in a Tupperware, and then you put the lid on the Tupperware, and then you carry that Tupperware to a walk-in, or you put it, I think there's at station refrigeration sometimes in the drawer below, or you have like an ice, or maybe it's not even on ice. But anyway, like those.
Like a sandwich bar.
Yeah. So all that motion of, if you look at one piece of onion, if it's going away, that's all labor and travel. And then and then you have to take the lid off every time you want to get something out. And then you'll just take out sort of the amount you need. And then you'll put the whole container back away. So like lifting that lid, scooping the stuff into the container, washing the cutting board after you do that prep, washing the container once that batch is done, all of that is waste. And to ignore that, so I was thinking in our shop, like every time we produce ahead of schedule upstream, it inherently means that we spend time moving it in an intermediate space. And that is waste. Right. And like if you could finish a part on the mill and immediately pick it up and put it into the next process, rather than setting it down a second time.
Yeah, I agree. To finish out the restaurant analogy, my assumption would be is that restaurants do that for the sake of leveling production, because during service hours, there's more work to be done than can be done by that many people in that space.
Yeah.
And so they front load some of the work.
Certainly. I think similarly, I would imagine that is true, let's say, for give them the benefit of the doubt for at least 80% of what they're prepping.
Yeah.
But I would guess that there's also very little examination of what process is making them batch it, right? Like, could we set up a would it make sense to have a little station right here that is just for chopping the onion we need?
Right. One person is just like chopper.
Yeah, or you just step over there, chop 3 slices off, cube them, and drop them right into your omelet, or I don't know what you're cooking, right? And like
onions go into everything.
Exactly. So I think, like in a shop, I think like one of the really useful things about reading all these books and talking and listening to this podcast now, I do listen to it, and it is fun. Is just re-examining everything. And I think from a global perspective, again, this thing driving around, just seeing all these like Japanese construction equipment, it's crazy that we're shipping. I don't know. It really gets me every time. But I think like you need to bring a level of attention to every one of these details to be competitive, because if it is waste, then if someone else shaves it out, they can either drop their price or increase their quality, or both. Yeah. Anyway, so that sort of push is overproduction and waste. So then pull. Maybe I can just describe a station, or you want to describe a station?
Yeah, I guess like this sort of ties into generally Kanban style system. It doesn't have to be Kanban, but pull would just be that you have a station that can produce a certain thing, whether that's a physical good or information or whatever the case may be. But it doesn't until a trigger that could be an email, could be a Kanban card, could be a direct order from an individual, triggers that station to produce the number needed. So, I mean, it's pretty simple, really. I guess putting it in terms of how we use it in our shop for tool management, it's kind of a classic use of Kanban, is we have our tool inventory that's set at a certain level, and we pull from that as we need it.
And when you say set at a certain level, it's like our 1/4 inch end mill, we want to have 5 in the building.
hopefully less. But
3.
yeah, usually 3.
And then that's the level, and once you pull that number 3, now you're down to 2.
Yeah, and so that sends the trigger to the next upstream process, which in this case is our tooling supplier, to order another 3.
Or it'd probably be your procurement process.
Yeah,
right.
Essentially.
And then they send it to the...
Yeah, if you were to break it down fully.
Yeah.
Yeah. So I'm not sure if I did a good job of describing that, but I think it's essentially using a trigger to stimulate the production instead of some aspect of like humans being like, I think maybe we're going to need this, or let's make it because we are prepared to do it, or we think a bunch of people might want these. Let's make 1,000 of them. It's like, no, we need these now. This is how many we need. Make the thing or get the thing.
And so in a pull system, basically you're trying to size your stock on hand to your replenishment time.
Yeah.
Right. So that just as you pull that last one, your delivery comes from your tool supplier replenishing your 1/4-inch end mills.
Yeah.
In the case of end mills, you want also some safety because sometimes you'll snap an end mill. I mean, from talking from my own experience, right? So like, but for us, so the way we have our shop laid out is we basically flow parts through our CNC. So that means, through our CNC, through our tumbler to through drying. So after we tumble them, we degrease, rinse, and then dry them.
Yeah.
So that's all flow, just meaning that there is every time one process finishes, it immediately goes on to the next process. There's no queuing. There's no. And we do have a queue ahead of our tumbler sometimes because our mill is faster than our tumbler.
Mm-hmm.
And that we've talked about on this podcast before. And it's probably something we should fix, but there's no triggers in there. So like the second one batch is done in the tumbler, the next one goes in.
Yeah.
And so it essentially parts flow with waiting, but they flow through from stock into the CNC, out of the CNC into the tumbler, out of the tumbler into the degreaser. When done degreasing, they get rinsed and immediately go into the oven and dried. And then they get weighed into bins, which is waste. So we weigh them into bins.
And where's the trigger points in that? Like, so you flow
so each
through...
bin has a Kanban in it.
Yeah.
And those get set on a shelf. And the number of bins we keep on that shelf relates to how many buckles we produce a day.
Yeah.
And this is probably our lack of production leveling.
Yeah.
Junka, I think. So we keep enough parts on the shelf to be able to do a full production run of any one of our buckles, essentially a full day's assembly of all of any of our buckles. So 60-ish buckles. And so that's one flow cell. And then from that inventory, the paint department can pull. So when the paint department gets a trigger from I'm describing this from the wrong end.
You're pushing it.
I'm pushing it. These are all triggered by orders. I should really have started at the other end, but just to finish out. So the paint department would basically ask the quote unquote machining department, like, hey, we need to paint parts today. We're going to paint, 3/4-inch cams, 3/4-inch bodies, and 1-inch cams, let's just say.
Yeah.
And so they would go pull from that inventory. And the second they take those bins, the Kanbans from those bins go back to the CNC to produce, to machine more of those parts.
Yeah.
Then paint basically flows through our paint into the oven, out of the oven to QC. And then once it's done QCing, they get put into bins at our assembly station with Kanbans in those bins.
Yeah.
And so that's our paint department is a flow. Our machining department is a flow cell. And then our assembly station also, and the Kanbans triggering our assembly station are physical orders printed off from our website, in this case, ShipStation. And then someone working the assembly station basically assembles those orders and ships them. So we sort of have these three Well, I guess we have two places where we build up inventory and sort of three Kanban loops.
Yeah. Yeah. So like to put it in, the goal of that would be to hold as little inventory as possible. So you're trying to ideally match your inventory quantity to your replenishment quantity and to your rate of use.
Right.
So
yes.
you can't forget about the rate of use. It's like if you use, what is it? I'm trying to pull these two concepts apart. But going back to the end mill thing, if you know you might use 3 end mills in a week and it takes a week for the new ones to arrive, you need to have 3 in your replenishment quantity. If you know, I'm trying to think of an extreme example in the other direction. You don't want to order 20, even though you could. And if it was going to take you a year to go through those 20, like you could set up a Kanban that orders 20 after you get down to your trigger of 3, and you take a year to get back down to the next order.
Right.
But then you're holding a lot of excess inventory. So the idea is that over time, through that it naturally gets to a point where you hold as little inventory as possible, but you never run out because the replenishment time matches the quantity held.
And I think a few reasons. So oftentimes people will order a lot to fix the problem of running out, but actually you're just deferring that problem. You're not fixing it, right? Yeah. Unless you have a built-in system of replenishment, buying a lot of something doesn't actually fix it. Mm-hmm. Another is sort of discount pricing, right, on bulk orders. But I think in thinking that through, it's important to realize that taking up space in your shop has a cost. Mm-hmm. I calculated that cost for our last shop. I haven't done it for this shop. But basically, like, what are you paying per cubic foot, right? And then there's a cost to stuff sitting in there. And it drives the need to have much larger stations. I mean, when you drop inventories, and we've seen this in our shop, I mean, you can save 30 to 40% of your shop space, of your floor space. And that means that every person who walks between stations has to travel 40% less distance. Uh-huh. There's a lot of sort of trickle down effects of holding inventory. I mean, this is a funny example, but we have a queue between our assembly area. Oh, I guess that's another. Yeah, so that's more inventory, but we have a queue between our assembly area and our shipping area because we don't have enough people to man every single station, essentially. Sure. Yeah. And so we sort of walk between them to do, we'll do a bunch of assembly and then they build up on this chute. Well, those chutes, I just measured them out the other day. It's about 14 inches for the 2 chutes, one bringing empty bins back to the assembly area and the other one bringing full orders to the shipping area. And that's 14 inches extra that we move past between our assembly area and the sewing machine. So that's wasted motion on every time we turn to use the sewing machine. We have to travel past those 2 rows of bins. Yeah. And it can become really easy to let that stuff fade into the background.
Yeah, I was just thinking about our shop and how there is nothing in our shop that we get that granular about because it is so variable. It is hard to even see.
Well, is it variable though? I mean, because I'm thinking about your shop, right? Yeah. A computer station is a place where you are interacting with information, right? Yeah. And information is a form of inventory.
No, I actually do think we've done an okay job of setting up our sort of in-station situation for flow. It's just funny where I don't know. It's just a difference of right. these very we do have our dedicated processes, and we do try and refine them. And maybe it's just a difference.
Yeah, I mean, I'm even thinking your carts, at every machine you have those benches, a small bench with sheet pans beneath, that sort of are used to hold jobs. Yeah. If you had gone man, it would be nice if we could hold a lot more and made those full height. Then you need an additional station for your tools and your your monitor and all that. And I think that's really easy to do.
Yeah. Well, yeah, we used to have those actually. We used to have a full height bun rack, a sheet pan rack
Right.
next to the machine. And then we were like, where do we put our other stuff? This doesn't work very well. Yeah, I think it's just going back a little bit. It's interesting how sort of like attuned we are to thinking in a push style, because I think because we tend to follow the process from start to finish, because that's how we think about it and design it. And the pull system works from the other direction. So it's like, it's a hard,
It's telling that I described it in the direction I did.
yeah. So I think it's really, it takes a lot of thought to really flip it on its head and start thinking from the reverse of, we get an order. What happens? It triggers this. It triggers this. It triggers this. Ideally, all the way back to the beginning. And it was funny kind of trying to place that in my shop, because like essentially what you get is you get an order and then the whole line is triggered and then you kind of knock things off as you go. And that is actually kind of how we ended up structuring our job tracking and flow.
Yeah.
We don't go through the process of handing off Kanban cards to each thing. It kind of like, it all just happens.
Right.
And then we tick it off as we move through it.
Right. And I could see Kanbans being useful as you get into bigger and bigger orders, from the machining to the saw cutting and to material ordering, because like if someone gave you a PO that was going to last 10 years, you wouldn't turn around and buy all that material, right?
Right.
And so what would often happen is you'd forget to reorder, or you'd have to be on top of reordering, or you'd have a calendar reminder telling you to go check inventory, right? And so, I was going to say like that.
We're actually dealing with that right now.
Oh,
where we got a blanket PO for the same number of units every month.
Oh, right.
And it is a little awkward.
Yeah.
With our current system, how do we handle this exactly?
Interesting.
And as you said that, I'm like, well, we should probably just have a Kanban that triggers this.
Yeah.
Triggers the ordering. Like right now we have a job for each one set up in our ERP, but essentially they're all triggered and there's no indicator of when to do each one.
Right.
So yeah, then it turns into like this thing of a reminder or some kind of other memory aid, whereas we should just have a Kanban that goes to like a physical thing when we ship that goes back to.
Yeah. And I suspect that
ordering.
that would be a useful thing across other jobs. Like I think you could probably push more work. I'm not sure it's your limiting factor right now. Probably not. But having a lot of stock in the shop just because a job is happening, if you're getting aluminum deliveries once a week anyway, you should only really keep a week of stock on hand. Right. And like the second you stack a lot, I mean, we both have pretty small shops. The second you stack a lot of stuff in there. I just got a batch of cut parts from you the other week, and I need to adjust my Kanban quantity because I don't have space for it on my stock shelf. And so now I have like a random pan sitting on like something else somewhere else that I need to remember I have there, and I need to not knock it over in the meantime and all that. And it's like,
I have a stack of aluminum outside my shop right now because we had a big order and I wasn't sure what order we were going to like run all the different parts.
Right.
And because our material only comes once a week, I didn't want to risk not having it.
Totally.
As kind of a
but even having it out there and not pulling it in and cutting it just because you have it and then stacking it again somewhere else.
It's been interesting trying to apply this in our job shop environment. I feel like we've gotten pretty decent at flow inside of a job. But when I look at the overall process of order placed to order for fulfilled, there's a lot of waiting. I'm still thinking through kind of how to tackle that and what the real issues are right now. Like when we go from sawing to finished parts, that's all pretty smooth and happens in a relatively quick
finished machined parts, right?
Finished machined parts. Yeah, we do. There is a big a big gap right now with post-processing and anodizing, and, you know, going away and coming back and adding 2 weeks to every lead time is starting to be like, it's not great.
Because you bill once you ship, or
Yeah,
when
we
you're
usually,
ready to ship, or something.
bill when we ship. So, I mean, it's not great from a financial standpoint. It's also not great just from keeping customers happy,
Right.
you know,
At
especially
2 weeks.
when it maybe takes from the point of order till we can get it on a machine might be 2 or 3 weeks.
Right.
And so pretty soon that stretches a lot. So it's been interesting looking at like, so we sort of inherently have a little bit of a pull system, and I think we have decent flow in station or even through our stations, but clearly there's some massive waste happening when an order is placed. And I mean, I think the bottleneck basically is our machines.
So just to push back on this a little for the sake
Yeah.
of exploring the ideas.
Not that we need more machines. I think it's that we need to figure out either how to run them more, how to have a little less downtime between jobs, or probably both those things is a big part of it.
Interesting. Yeah. And hearing you say that, I wonder if what's actually happening is once a job is triggered, there is, and I'm thinking maybe my station, I'm conflating flow and push. You're sort of pushing that job through the system, right? Because like and maybe you're not. I don't know how you're doing it exactly, but I think flow would be like when a part, single piece flow would be
single piece flow, yeah.
a part gets cut on the saw, it immediately gets passed to the mill, which immediately runs it.
Yeah.
Batch flow would, or batch, not single piece flow.
Yeah.
Batch flow would be you cut, say, 10, and that gets passed to the CNC, and that all gets run as 10. And then when 10 are done, they get passed immediately to inspection or deburring or.
Yeah, we batch our sawing, and then we try and run single piece flow through our machines and through not always single. It's usually small batch through tumbling and stuff like that.
The tumbling is a pain, as we've discussed.
Yeah. And then batches obviously go to anodize.
Right.
So there's definitely waiting at certain stations. I don't feel like the batching of this. I can feel like batching sawing still makes sense because it is something that feeds so many different processes.
Yeah.
And usually that stock taking up space is not a super big deal. Right now, it's kind of actually a hassle because we're working on larger parts and we're kind of like, oh, where does all this go?
I think just for sake of exploration, I was thinking about this on our mill. How would you behave differently if your saw had 10 buttons that you could pre-program? So you just click a button and it would cut one piece of a pre-programmed stock size.
Yeah.
You know?
I think, well, it does. The material handling becomes the issue.
That's what I'm saying. Yeah. Right. So like it sort of highlights.
It had a magazine and could just spit out bits.
I feel like you'd order sort of what you're going to load into the machine next.
Yeah,
right?
Definitely.
Or something like that.
I
don't know.
I mean, yeah, we do try and not oversaw for the sake of like if I made errors in a cut length or we need to adjust things.
So do you cut for like a day or do you cut for a job, or it sort of depends on probably the size and stuff like that?
Yeah, we usually cut for a job, assuming it's, not thousands of parts.
Okay.
Yeah. Right. So if it's like 20 to 100 pieces or even 200 pieces maybe, and we have the space.
Is that systemized in any way? I wonder if you're thinking with every, like if the saw operator every time has to think about how many should I saw, or is it made explicit?
It's relatively explicit. Right now it's basically quantity plus one because we want a proof part.
Right.
We're guaranteed we want a proofing out part. And then we will saw extra if we mess up more than one. So I guess
unless it's thousands, in which case.
Yeah, which kind of getting into the weeds here, but I think generally speaking, we, for the most part, only do that on the lathe, and that kind of does its own sawing, as it were, parting off.
Right.
And then, yeah, like right now we're running 1,000-piece part, but it was all pre-sawn stock.
Gotcha.
So, yeah, in general, it's just quantity plus one.
Interesting. So I don't know if that kind of
Yeah, maybe we're beating a dead horse a little
wraps
bit.
us up on the
And
push pull flow. I'm sure we didn't. That wasn't super succinct in any way, but
if people want to hear more about it, definitely reach out.
yeah,
Or if you have stuff to add, because as mentioned, we're not experts.
certainly. And I would say this is like very covered in all books
All
on
books.
lean.
Yes.
So crack a book. They're quite good.
They are good.
Do you want to jump into
Yeah.
some things we have here? Yeah.
Sorry, go ahead.
So I have a few here. I guess maybe this is a nice, this very much relates to push, pull, flow. So reducing batch size on the mill and flow through paint basically is something we've been looking at. So rather than the assembly station basically pulling parts from, rather than the paint station pulling parts from the machined, pre-machined parts that we just discussed, the bins, um, basically having the assembly station trigger machining directly instead of having it trigger the paint department. And so the Kanban cards from our assembly station would essentially go to the mill. The mill would machine those parts, pass them off to paint. And so we'd essentially be flowing. We'd eliminate a bunch of inventory.
How do you handle color quantities?
So this is a big transition we're trying to do, which is right now our Kanban quantities on our assembly station, regardless of the popularity of that particular color, is 32.
Yeah.
32 on some parts is not enough. And on other parts, that probably represents, I don't know, quite a while. Yeah. So we definitely need more quantity on some parts and less on other parts. The other thing is the number of buckle, like that trigger size is insufficient information. We're sort of batching, passing information to our paint department. If you think about it, like every time you pull apart and information is not passed upstream that part was just used, you are storing that information to a later date, which is batching the information. And so this is a separate conversation, which I haven't read anything about that I can remember in any of these books. And I kind of want to find a book specifically on information flow and Kanban, because there is huge value, in my opinion, of taking an existing pile of stock, even if you don't want to reduce how many you keep on hand.
Yeah.
There's a huge advantage to breaking it out into smaller quantities that trigger upstream. So like instead of having one batch of 32, we're going to switch to 4 Kanbans of 8. And what that does is now every time we dip into the next 8, it passes information upstream to say, hey, we need 8 more of these things. And that has issues in our case with the paint department and the time it takes to switch colors.
Yeah.
So I don't think we're going to end up painting more colors per day necessarily, though we may, and we are working on ways of making that a much faster process.
So are you going to paint in smaller batches?
I think what's going to happen is we're going to aggregate them onto a board and then paint we'll still only paint 4 colors per day, but we will paint for availability instead of painting essentially in the order that they were triggered. So if when we walk up to the board and it says like orange cams are one of the parts that just like we rip through. And so if there's 4 Kanbans on the board for orange cams, we know there's less than 8 at the assembly station, which is a big problem.
So you get more granular information as to your actual usage, even though your batch size stays the same.
Yeah, and so we may shrink the batch size. So in this case, we may only paint 8 of one color, but that would allow us to paint more than 32 of a different color, right? So again, back to the orange cams, there are many situations where we should do more than 8 because like more than 32, which is our current batch size. So we'll often paint 32. They'll go to the assembly area and immediately the card will get triggered again. And we need to like essentially the next day. But in our current process, that Kanban is now behind a long queue of Kanbans that just
happen
to get triggered in that time. And so they're ahead of it in the queue, even though they're way behind it in terms of urgency. And so we're making these executive decisions of reordering our assembly plan, our paint schedule.
So thinking through like what happens what happens when one of your low demand parts still gets to that ultimate trigger point of needing a full batch and your high demand is behind it. Do you then jump it, or do you still run that?
So this is where we start to have information breakdown where the system we've built doesn't actually reflect urgency. And so often I will walk back and forth. Mm-hmm. I'll go check on our stock. I'll sort of glance at our orders, right? And make a...
Well, but with the new system, where if you're going to have Kanbans of 8, or Kanban cards of quantity 8, and you have, like, you're still going to have the situation, right, where a low demand item will build up and be ahead in the queue of a high demand item.
So yes, except that what we'll essentially do is, it's a little complicated, and I'm just looking at the time here. What we'll essentially do is have a board with all the different colors that we paint, and then all the parts get triggered into those different colors. And so if there's a day where we're painting orange cams and there's a card for 8 orange bodies, or orange cams of 1 inch instead of 3/4, we will also paint those. We will sort of add them to the batch such that we're not adding color changes, but we're sort of making sure to hit those high demand items, but we're also mixing in the cards from the other ones. Hearing you say that, it's making me realize that we need to, on that board, reflect how many Kanban are circulating in the system for each part, right? So if we only have 2 Kanban of 8 for coyote bodies, but we have 6 Kanban of 8 for orange cams, then the orange cam Kanban stack on the board will essentially be way higher, even if we're completely out of coyote bodies. So I'll have to think about that.
Interesting.
Yes, but basically moving to triggering the mill instead of, so eliminating a whole rack of inventory, which is about 4 square feet out of our 300. So,
gotcha.
Yeah,
interesting. Did you highlight this for me to talk about, me going away?
Oh, I didn't, but it's just where my mouse was.
Gotcha. I'm just going to go through some of these points I had in order.
Yeah.
I realized I had this, so I've been thinking a lot about Workholding, as we discussed last time, or a couple different times. And I realized it's going to sound silly now that I say it, and it took me a while to realize it. But I realized that we've really optimized around using the Carve Smart Softjaw material.
Okay.
Because it is so convenient, to the detriment of the rest of our setup.
And to unpack that for anyone who doesn't use Carve Smart, or use a milling machine.
Or use a milling machine. Basically, for the non-machinist, when you machine a part, generally speaking, you hold on to the rectangular or round bar that it's made from, and you mill your part out of the top, and then you're left with a part that you were holding on to. If you were to, like, imagine cutting up a cucumber, for example, you cut it, and then at the end, there's a little piece that you're holding, and you can't chop that. In this case, you can't just throw away that little piece. You need to use it because it's part of the finished part. And so the common method is to mill a negative space into a pair of vice jaws that are softer than are just not extremely hard.
Not hardened steel.
Soft enough to mill. And then you flip your part into that negative space and clamp on it. And Carve Smart is a brand that makes an extrusion that has a dovetail on the back. So it's very, swapping them out takes a matter of seconds. It comes in long bars, so you just cut it to length and you can stick them in. It's incredibly convenient. It works well. It's repeatable.
Yeah.
So I think just in the evolution of my career as a machinist, I started as a manual machinist and everything was around, Kurt Vices, and then slowly transitioned. And um, so we've really optimized around using these jaws because they're so convenient. Most of the 0 point centering vices have some sort of proprietary jaw interface, and often their purchased jaws are very expensive. So I've ordered material to make my own for the new shank vices. I've made my own for the 5th-axis type in the past. I bought them for the orange delta vices, which are sort of a centering vice.
Mm-hmm.
Those are extremely expensive. I mean, in the grand scheme of things, they're not, but when you're using a pair a day or sometimes more, it starts to add up. And when it's like, 30 to 40 bucks a set. And so it's just this interesting realization that I think, like, subconsciously hesitated from making this big switch because I wasn't sure how we are going to tackle this part of the workflow effectively. And to kind of like put it in perspective right now, we have had this stock for these new jaws sitting in the shop for like 2 months, and we haven't had time to schedule making these soft jaws on the machine.
Right.
So anyway, I just wanted to talk through it and just be like, how do we handle this? Or is there something out there that exists?
So I've read this. I'm not sure why those are mutually exclusive, because I think the idea with a 0 point is that when the operator puts the vice back on the table, there's not a process of figuring out where that vice is.
Absolutely.
And so even with a Carve Smart vice, like an orange vice, if you have the orange vice standardly configured, if you come up with a standard configuration for like an orange dual station vice,
mm-hmm.
then the G code you output in your model should, on a 0 point system, should go to the right place on your orange vice, right? So like,
yes,
you'd have it all modeled based on like whatever your 0 point is.
Yep.
Would that help? I mean, just
it could. There's some other, like we've discussed in the past, there's different ways of configuring the vice.
Totally.
There's also it's a small detail, but it is a detail of a vice that only clamps in one direction tends to move the part.
Right.
As the vice itself compresses or the part compresses. So you have to manually do some tweaking usually to get the alignment from op 1 and op 2 perfect. Like even if you cut the jaw in place, I've found that usually the actual placement of the part when machined is a little bit off, and you have to do some manual adjusting of the offset.
Is that because you're not preloading the vice at the top of the jaws, or just?
I don't know. I do preload. I feel like I have pretty good like best practices around that.
Interesting.
And I'm not sure what it all comes down to.
And you don't have that issue with centering vices?
Not to the same degree.
Interesting.
Well, because it's all just compressing to center, and your 0 point is at the center.
Right.
So you may be getting distortion, but it's equal around the part.
Interesting. I would think that the slop in that system, where you have two moving jaws, I mean, I guess the shank vice is pretty damn good. The centering vice.
They're very nice, yeah.
Or the pneumatic one. Anyway, interesting. Okay, that makes sense.
So that's a small detail. The other detail is just from like a cam flow setup standpoint. Mm-hmm. If it's all like actually oriented around a center axis, and you can align your stock and your part to this center axis, everything is centered. Your two vices for op 1 and op 2 are centered.
Right.
It's very simple and straightforward. There's not a lot to like think through when you're doing the setup. Whereas if you kind of add this like off center vice situation, it's doable, but it's a little more to think about. And then if you're adding in probing, at least with the way our post processors are set up, it makes probing a lot more difficult unless you're going to set up an alternate work offset for the part where it needs to be probed. Because as things currently stand, it probes the 0 point. It probes the WCS. So if you wanted to probe, you can't probe a part that is not aligned with the origin.
Sorry, I know that is something
in the weeds. It's possible. It is potentially coming.
Okay. Yeah.
Anyway, any thoughts on how to cheaply make custom jaws?
basically carve smart carriers,
That
or
or
just anything that achieves the ease of
yeah,
making soft draws.
yeah.
Well, I guess one thing that I always come back to is like there have been a lot of smart people who have thought about this, and we
Hmm.
see sort of the best that they've come up with,
Yeah.
right? And one possibility is that they're not optimizing for your situation,
Uh-huh.
which would mean that there is an available option that is. We've sort of discussed making carve smart carriers for the centering pneumatic shunt vise,
Yeah,
which is still tempting, I have to say.
it is.
Yeah, I mean, honestly, like our quote from I think it was last week was do act your way to a new way of thinking rather than think your way to a new way of acting. Right? I do wonder, like I feel like we've kicked around so many ideas but haven't prototyped any of them,
Yeah.
that it would become pretty obvious pretty quick where the good ones were, or what issues, what things we were forgetting to think about, or
Mhm.
if we just made some. I think, I mean, I think it's a very good realization to just see like where the friction is coming from,
Mhm.
because I feel like that's often the crux of it is like, oh, we need a better workflow for our up to soft jaws, right? Like that's sort of what that is,
Yeah.
and that's holding up a lot of other standardization because you're hesitant to move away from.
Convenience.
Yeah. Um, is there not a? Could you not just buy a set of like Kurt Weiss adapter, right? There's jaws to go from Kurt to Carb Smart.
Mhm.
We've sort of talked about this. Could you just buy one of those and cut it to the length you need and mount it on like a
Just a carrier.
different centering vise?
Yeah.
Just like an aluminum carrier, and just see how that is. My guess is you'd run out of, it would eat up a lot of vise
Travel.
travel.
Yeah. Yeah, it's worth
But
exploring.
it might be pretty nice for all the ones that do fit. And then you're like, okay,
Yeah.
cool. Let me put the energy into
Something that's like
yeah.
dedicated.
I don't know.
I like that idea. That seems like a very actionable sort of like test bed.
Yeah, just see if it
Mhm.
does the thing.
The while we're discussing, the Kurt centering vices are notably superior than anything else. Or sorry, the Shunk centering vices notably superior to anything else I've tried in terms of their fit, and like their fit is so good that like turning it with a wrench is like when you tighten it,
Buttery smooth.
well, it's buttery smooth, but like just has that little bit of stiffness where you're like, wow, the fit on this is incredible. And when you put the jaws in the top,
Yeah.
or when you try and take them out, it's like
Wow.
and then they come out, you're like, oh, well, that's
I heard
very
the
snug.
pneumatic, the Shunk. Yeah, the fit and finish on all the Shunk stuff I've seen has been really very impressive.
Yeah.
I heard it described as it looking like it was made by aliens.
It's true. Yeah. Interesting. So you want to go back to one of yours?
Oh no, hit us with another.
I went away from the shop, and the shop kept running.
Amazing.
Which was amazing. There was also some
wailing and gnashing of teeth.
some wailing and gnashing of teeth. Some very good things were highlighted. Don't really need to get into the specifics, but it became very clear how much we rely on being able to communicate in person,
right?
At a moment's notice for little details that get forgotten.
Isn't that so cool? Yeah. This is big.
So I left on a Thursday.
Mm-hmm.
Friday they ran totally smooth because they were just kind of going through stuff. Monday, I think things were pretty smooth. Tuesday, phone started blowing up, and it was like, oh, I'm texting constantly.
Right.
And so I don't know. There wasn't any like specific well, there was a few specific takeaways, and we had a meeting when I got back about like, let's notate the things that were notable.
That's
here.
So cool.
But basically it just comes to me putting trash information into our setup sheets, or
yeah.
or there was a few things that were like oh god, my brain just went blank. Verbiage.
Uh-huh.
So
Just unclear.
because we don't have a template right
Uh-huh.
now, and I'm writing every setup out from my head. For example, I started using 0 point instead of rock lock base, because rock lock, like 0 point,
Uh-huh.
is more universal.
Right.
And I'm thinking about, different ways to approach this. And so in my head, I switched how I was thinking about it. And so Ariel texts me. She's like, "What's a
What?
0 point? Like, do we have one of these?" And I was like, "Oh, it's just the thing." Uh,
Interesting.
so yeah, there's been a lot of things where it's like, I need to standardize verbiage. I think it's going to be nearly impossible for me to do that, like, just by forcing myself to like use the same words without some template to follow. So we're coming back to this template thing,
Totally.
which, to anybody who's like, just do it already, it's like there's a bunch of other things involved, and we're talking to somebody about building out a new Airtable base and stuff. So
Interesting.
it's going to happen.
Yeah.
But it also it's been highlighting that our like tool management system needs some updates. And one thing that became very clear is that right now we're still running some old programs that used old tool definitions, and kind of the way we set up the post to output the stick out for the tool in the header.
Okay.
And I copy and paste that into our tool setup sheet so that I don't have to do manual interpretation.
Okay.
And when we started, it was kind of like, the stick out here is God. Like,
Right.
do not ignore it. That's one of the most critical things here.
Totally.
However, old tool definitions didn't have that set properly. They were just like a default. And so you'll have like a tool that comes in and it's like a 2-inch overall length. Cam decided that like this diameter needs to have a 2 7/8 stick out.
And you're like, well, that doesn't
work. And so now Ariel doing the setups, she's like, I don't trust any of these. And so she's like having to come check in with me.
Gotcha.
So it's just like one of those, garbage in, garbage out. You need to maintain just like absolute consistency. Otherwise, all of the information becomes useless when you can't trust it.
Right.
And the other issue we've had is we set up these standard tools, but right now we do have to adjust them fairly often.
Okay.
For an oddball stick out, usually. And we don't have a good way to distinguish when it's in that altered state. So we need we're probably going to do some kind of colored tag that goes on the job tag when we've altered it. Like when it's in the machine and it's not in its standard state, some sort of color that indicates that it needs to be reset.
And you're never going too short, but if it's standard and it needs to be longer, it is too short.
Yes.
Okay.
So it's almost always too long. It could be worse, but occasionally it might be set short for like, we want better rigidity. We're cutting titanium or something.
Gotcha.
Either way, it needs to go back to what it was at some point.
Right.
And then we also need a way to distinguish. Right now, we are setting up new tools that are maybe not going to be standards, but we set them up in CAM with all the information of a standard tool, including like a number that an ID number for the rotating tool assembly. But there's no way of saying this should be broken down after we use it because it's not a standard. And so then those start to just like occupy tool holders, even though we need them for standard tools.
Interesting.
Yeah. It's an evolution. It's cool that these things are coming up and that we're noticing them and
no, totally.
figuring out how to tackle them.
When I bought the headset, I guess you have one too. The one with the mic.
Yeah.
I was like, oh, maybe I should get these for everyone in the shop, and then we can download two-way radio apps, and you can just talk without walking across the shop, reduce waste. But then I realized reducing the friction to go ask someone a question, besides the issue of interrupting, is the issue of not logging that question as why did this question need to be answered? Like, what is that? And it's so easy to, I don't know. I've put this in a few times, but just like a note, basically like it's so hard to just interrupt production every time something comes up once you start seeing more and more things.
Yeah.
Right. You sort of have a note about this time, right?
Which one?
I forget. That it, like when you start seeing waste, it becomes overwhelming, right? And it's like, if every time I talk to Sam or Mark or they come and ask me a question, we walk over to a whiteboard together and write down that question. And then the next morning visit it and say, okay, why did we need to ask that? How can we fix it? Like, it becomes crazy at the level we're at, which is really far away from perfect. Right. And so maybe that speaks to needing to improve our system for logging issues, which we have done a little bit. We're now using something digital so that we can carry it around in our pockets, which has a separate issue of not having any real bounds. And so you end up with huge piles of
same thing,
semi-useful data.
You end up with a lot of stuff where you're like, you have to sort through and you're like, is this real or is this trash?
Yeah. So
I do think physical, like having physical places to put information really does help mitigate that.
I've seen so many shop tours, like seeing you go to a like some software for your job management stuff. And then moving back to a physical board. I've seen so many shops that use physical scheduling and physical job boards, essentially. I think for a lot of the reasons. Even really quite large companies, it's hard to make software simple. I don't know, like having, it's interesting. Even though it's so much less powerful and so much more manual, it seems like it would be way more wasteful.
I think historically I've been pretty good at recognizing waste in our like discrete production processes and optimizing towards flow there. I've not been good in the past at seeing waste in all of the ancillary processes, and I'm starting to see it. And yes, it is absolutely overwhelming, especially when, there's this like bucket list of things to do still just for our production processes. And then I'm sitting there typing out a job setup sheet and I'm like, this is all waste. This has to happen, but this is all waste. And it is extremely, it's like if I were to like let myself think about it all, I would be utterly demoralized. So I'm trying not to think about it all at once and just like take a little piece at a time. But it's wild once you start to recognize it.
So I was watching some Eliyahu Goldratt talks, and he was sort of talking about like, where do you focus improvements? I think Lean and TPS, Six Sigma have very good tools for improving things, but I don't think there are explicit tools for prioritization of where to improve and what to improve. And I think it would be useful. I think I'm hoping to kind of get a little bit more information on that. I mean, I've read his books, which I don't like, but I mean, just he writes fiction, which makes no sense to me. But his lectures are really good, and theory of constraints generally is much more focused on figuring out where to improve and much less focused on, 8 lean wastes and all these other really interesting and powerful things. But when applied, like the way Toyota writes about it, it's sort of like you need to chase out every bit of waste everywhere in your company.
Like, just do it all, obviously.
Anytime there's an issue, stop. Fix the issue.
Start now, and we'll talk in 20 years. When you've done half of it.
And we've made huge strides in terms of our production numbers and efficiency and all that. So it's been really powerful. But I think to your point, like anywhere I look in the shop, there's just so much waste, and it becomes overwhelming when everywhere you look, there's like, okay, I could do work or I could fix this huge glaring problem. Start sort of running in circles a little bit.
We're about up on time, but there was one little piece I wanted to mention that gets mentioned a lot in any discussion of TPS, and Toyota mentions it a lot explicitly in their like statements and public statements. But no one ever seems to go into much detail about it. Maybe because it's just simple and obvious, but they mention workplace safety a lot. And I think as like solo business people, It's not something we think about a lot.
Mm-hmm.
And I had a couple experiences recently where I was like, we were unloading heavy stock. We don't have a forklift. And I was like, this is not safe. And this is not something I can expect somebody to do who is just here, essentially for a paycheck. Like, it's not their business. They don't need to sacrifice their body for it.
Right. And shouldn't.
And shouldn't.
And also we shouldn't.
And
but
we shouldn't.
But we do.
But we do, because it's, kind of that, whatever that is, like that give it everything grind mentality or whatever.
And forklifts are expensive.
Yeah, ish.
I mean, it's just another thing to spend money on. It's
another thing. So I just want to include that in the conversation as like something to keep in mind. And I think it does loop back to the like retention of employees and like making them feel valued and buy in, all those things.
For sure.
Yeah.
I think about that a lot. It's something I try to prioritize because of the way it's talked about. I think, like, for me, basically, I think like safety has to be number one. And there's definitely issues in the shop that I should fix. But I feel like the second I realize it's a safety thing, like we have a loft, and right now we have a ladder, and that ladder was just like leaning up against the wall. And so now it is it's secured, and that is way safer. Right. I mean, it's basically a steep staircase at this point.
Yeah.
And, installing fire extinguishers and all this stuff. I think it comes down to like respect for people and putting your money where your mouth is, because I think in the US there's a historically semi-broken relationship between like management and labor, and what that amounts to is
maybe entirely broken, not just semi-broken.
Yeah, but it's like this weird thing where employers are kind of leveraging the human connection of like people wanting to belong to a team to be like, you should give it your all, and like we really need you guys to push hard, like the company's going through a hard spell, or we have big goals and work nights and weekends to make them happen. And then on the flip side, when there's a downturn, it's like, sorry, you're fired. Right? Like, we're laying you off. And it's like, wait. And then in terms of efficiency, historically, management has asked workers to be more efficient and work faster. And then the reward is basically being told like, okay, well, that's the new set point. And if you're below that, now you're in trouble.
Yeah.
And so that's really been demoralizing historically for people to want to improve systems. And I think it is fundamental to having a lean culture for it to be really clear and very, like, you have to spend money. Otherwise it's like, you're like, so what? Like, it's all talk unless it's actually costing you something. But it's like the workers are the most important asset. And like, yeah, I don't know. You gotta, I think the safety thing is a big part of that.
Yeah, definitely. So that's high on the list. We did have a discussion about where to put money, and everyone agreed that a sump vacuum was a higher priority right now, since this.
Yeah, that's another nasty job.
This large stock order was a little bit of an aberration compared to our standard. So they're like, whatever, don't optimize for that.
That makes sense.
We'll do it at some point. But
right.
So that's probably it for this. We are, as usual, over our goal time. Flow, push, pull. If people have more questions or input, thoughts, experiences, send them our way, and we'll loop back to this and revisit it. And
for sure. As always, please follow us on Incremental CI on Instagram, and that's a good way of getting a hold of us. We do read all the messages. Please continue to tag us in improvements. That's been fun to see.
Yeah.
And share. And that does it. Yeah.
Thanks a lot. And one last bit. We are going to switch to this new format. So we will be doing a Wednesday, Friday release. Wednesdays will be kind of these big picture discussions, and Fridays will be a focus on in-shop improvements, and hopefully get a little more in-depth into those aspects. So we'll see you next week.
And by next week, you mean Friday.
By next week, I mean Friday.
All right.
Bye.